G'day. In this series of videos, we're combining Psychopy and Python programming to create the line bisection task. This is about the fourth or fifth video in this series, where we've started with nothing and we've slowly built up an experiment that will test for visual-spatial attention using this thing called the line bisection task. And if you haven't seen those previous videos, I suggest you stop here, go back and watch the first couple of videos and work your way forward. Now, I have taken my time and really slowly built up the ideas, our approach to how we build this experiment. And so if that's something that you're interested in, or you're not quite strong with Python programming or how to design experiments from scratch, particularly in the neurosciences, visual neurosciences, then go back to the start and work your way forward. If you have seen those other videos, you'll know that we left off controlling the line length and which side of the line was longer, and we were able to randomize that every time we run the program. And I said to you that what we're going to do now is we're going to turn our attention to recording the responses from our subject and creating some way of saving that data as a file. We're going to use a file format called .csv, comma separated value, or basically it's a file format that can be read by Excel, or you can import it into pandas, or you can import it into Python or MATLAB or anything like that, and then do your offline or post hoc analysis on that. So what we're going to do in order to create that data structure, we have to first think of well, what are we trying to save here? What's the measurement that we're trying to get? And so in my mind, I'm thinking of a spreadsheet where we've got some columns and we've got some rows, and that what I'm thinking is that each row should probably contain the information for a particular trial. And so in our case, we've got 40 trials per block. And so therefore what we should probably do is generate a spreadsheet that will give us, say, 40 rows. And what sort of things will we need in this spreadsheet? Well, we will need the trial number. We will probably need, say, our subject initials or our subject identifier, because if we return to this data in 3, 4, 5, 6, 12 months and you haven't got data integrity in generating your data and then storing that data, then you've got lots of problems and you need to go figure out how you're going to do that. So our data file is going to contain the subject identification. The other thing that I want is the time of the trial. And I then want to have, say, the length of the line for that particular trial, how long the line was, whether or not it was left longer, right longer, or bisected. So remember, that's going to be 0, 1, or 2. What else do we want? Oh, we also want the subject's response. Okay, did they think that it was left longer or right longer? And what else? And we'll also probably want at some point the latency. So how quickly did they respond after being told to respond, basically? Is there some idea of certainty, or how quickly, or reaction time? If they're 100% correct, do they respond quicker than if they were a bit uncertain, took them a bit longer? So this is a common thing to record at the same time, latencies. So we've got a spreadsheet, we've got lots of columns there. The way that we can create this is by using a data frame in pandas, Pandas. And so I also think that pandas comes along when you download and install Psychopy. And so pandas is the name of the what you will import, and what we're after is this thing called a data frame. Now, the way that you can generally think of a data frame is basically a 2D, so two-dimensional collection of information. On the one dimension, you'll have some information, so columns and rows of information. This is different from a data series. So pandas also does a data series, which is basically just a one-dimensional data set. So it'd be a column, or it could be a row if you transpose that. So in our case, we want 40 rows and we want some columns, and so we need to have 2D information. So they call it, so here we go, a two-dimensional, size mutable, you can change the size, potentially heterogeneous tabular data. So that means you can have some strings in there, you can have some Boolean values in there, you can have not numbers in there, you can have floats in there, you can have double precision, you can have different sorts of information within this one data frame in columns and in rows. Now, we have to construct this data frame before we then save the data frame as a CSV file. So how do we do this? Well, let's just have a very quick look in our sandbox to see if there's any sort of things that we can play around with. So if you'll see here, I've imported pandas as PD. And so anytime that I want to play around with a pandas function or a class or anything like that, I can just go, hey, PD dot something something. So let's have a look here. We've got stim side, so eventually what we want here. Okay, let's have a look. So let's use this. So pandas data frame. So right down the bottom, we'll create our data frame. Create a data frame. And because we want to save it eventually, we will have to give it a name, and then this will become apparent. This will become important later. So let's just call it output file equals PD, remember we want the pandas, data frame. So now that's a capital D, capital F for data frame. And then we have to pass it some parameters. What are we going to pass it? This is a little bit tricky. We need to pass it the data that we are collecting from our experiment. And so here we go. Parameters, data. So it can be a dictionary. Okay, so key value pairs. It could be arrays. You could pass it a whole lot of arrays. You could pass it some constants or lists. So it looks like it can accept a lot of things. What we're going to do is we're going to pass it we're going to pass it a dictionary. I believe it's called a dictionary. So we need some braces, so curly brackets. And what we have is we have something separated. Okay, so we have a key and we have a value for that key. So it's key value pairings, not vale, that's not Roman. Okay, so key value pairs, this is what we need. Now this should hopefully become more clear as we flesh this out. So what we are going to do is we're going to basically pass the data frame a column of data essentially. And so on the top of the column, we want to give it a name. So when you open your spreadsheet, you know, hey, the first column is the trial number. So let's say the first column, we want trial number, something like that. So then we know, hey, the first trial, it was this. The second trial was this. The third trial was this, blah, blah, blah. And then what we want to do is we want to then give that the array of values that correspond to those trials. In this case, the arrays will be 40 items long. Well, let's have a look. What can we pass in here? Well, here we've got an array that we've created in our sandbox. We've called it stimside, and it contains 40 trials, and that we know that the first 15 trials have the number 2, and then the number 1 for the next 15, and then 10 at 0. And that we random.shuffle this. And so here we've got an array. We've created an empty array, and then we've basically shuffled that array. So what we can do is we can basically pass into this value the name of the array. So we can say stim side. There we go. So here we will have a single column of data basically with the number, with the title of the column heading being trial number. And then it will have stimside, the values of stimside underneath it. So let's see what we get. So how do we look at what's inside our data frame? Well, simply, we'll just print it out. Okay. And so if we run over to our command prompt and we run this, if we've done everything correctly, we should get a printout of that column of data. And there we go. Here we go. So trial number is the column, and then you can see 2, 2, 1, 0, 0. Well, let's have a look here. This is the randomized array that we created. 2, 2, 1, 0, 0, 2. So here we go. We've got a column of data. Now you might ask yourself, well, what's this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 on the left? Well, this corresponds to the index. Okay, it's the index position of each of the rows of data, and that's what pandas uses. And so you can see here, index used for resulting frame will default to range index if no indexing information or part of input data. So if we say here, comma index equals false, I think it's false, not none. It should not give us that information, hopefully. Okay, so bool has no length 0. So, okay, we do need to pass it, or I've done something wrong there. The point is, we don't need to worry about the index at this stage. So that was a mistake. So index, that's index from my point of view. Okay, so here we go. We've got the column heading. We've got the data that corresponds to that column heading. How do we build our spreadsheet, our CSV file, our columns and rows of data? Well, here we go. You'll note here that from date time, I've imported date time. Well, what we can do now is we can say current time, okay, equals date time dot now. We want now, whenever that program is run, we want now. But what we want to do is we want to format this. Okay, we have here string format, date time to string using strftime, because what we want to do is we want to say, okay, get the current time now. And the way that we do that is from the date time library, we get now, and then from that we want to only get a certain part of that time. Now, we want only the hours, the minutes, okay, the hours, the minutes, and the seconds, like that, okay? And so therefore, whenever we run this program, print car time, cura time, it should print out the time at which that program was called, or that function was called. So let's have a look here. We're printing out our data frame again. We don't particularly want that. So here we go, 15:37:42. And if we have a look up here, it is currently, 3:37 Australian Eastern Standard Time. Okay, so that's good. We've now got access to the time. Remember, one of the columns that we wanted was the time of that trial. We will stop printing out the data frame. But what we will do is we'll create another empty array and we'll say car time, not cut time, current time, time array, empty array please. And then what we want to do is we'll just go car time, cut time, current time array dot append. And what do we want to append? Well, we want to append now, which is being formatted. So I'll just Control C that, Control V that. And so therefore, we can now create a second array, okay, which contains completely different data. My finger moved then twice. Okay, it contains completely different information. Now, the other thing that we can do is we can actually create a trial number array. Okay, we called this trial number before. We'll get to that actually. Let me just create another empty array to show you what we can do. So we want to now go trial number dot append, and into that we want to append the current iterator, because remember, that's the current trial that we're interested in. And so at the end of the day, we're going to have essentially 3 arrays. The first array, we're going to have stim side, and then we're going to shuffle it. So it's going to be the shuffled stim side. We're going to have the time, and we're also going to have the trial number. Now you see we've created this in 3 different orders. We essentially create the stim side followed by the time followed by the trial number. But that doesn't matter, because down here when we create our data frame, the order with which we create the data frame will give us the order or the position in the columns that we're interested in. So the first column that we want, We want trial number, so we'll put trial number. Okay, and then in the next column we want, let's just put the time, so time of trial, and we'll put car time array. Okay, brilliant. And then in the third position we want stim side, so stim length side. Okay, and then we'll put stim side there. Okay, so what we should expect to see is 3 columns plus the index, because remember the data frame will come with that index on the left hand side. In the first in the first column we should see trial number followed by the trial number. We should then see the time, and then we should see the stim length side. It's 3 separate columns. Let's see what we get. We're running it. Here we go. Bully for us. The first column we have the trial number, and then we have the time. Now you'll see it says 15:41:14. That's because it did those 40 trials super quick. I mean, it's a very quick CPU. And then you see the stim length side. It's 022002121. 022002121. So here you go. We are starting to build our data frame, and we can add whatever we want onto this now. So if we just put a key value pair, so key followed by a value, just as long as the values are of the same length. In this case it's going to be the same length because we only ever do 40 trials or 5 trials or however many trials we have in our main program loop. We've now created our data frame. So that's the approach. This is essentially what we're going to do in our main program. So let's go back to our line task program and get all this up and running. So once we've done all of our main program loop, now we want to, before we tidy up, we want to create our data frame. And then essentially what we will eventually do is then save our data frame. Okay, but first we need to create it. How do we create it? Well, remember we had the output file equals pd.dataframe. And for us to access this pd.dataframe, we need to first import pandas as pd. So we go up to our import. We say import pandas as pd. Great. That worked. Yep. And so now what we can do is to create our data frame, we'll say output file, file equals pd dot capital D, capital F frame. Okay, and in that we want, remember, the key value pair. Okay, so in my mind, remember, what do I want? I want the trial number, and then that will be the value for the trial number. I then want the subject ID. Okay. Now that's going to be the same thing again and again and again. But just in case you want to mix and merge files or do SPSS stuff or something later on, it's always good to keep all of your data integrity intact. And so every single time you have raw data, you know who it is, what time it was, what date it was, all that. We'll just do the time for now, but you should be able to use the strf time to also get the date. No, we'll put date in. So trial, subject ID, we'll then get the date. Okay, the experimental date, and this will be the date. This will be the value for the date. So I'm just thinking the columns now. What else do we want? Time of that trial. Okay. What else do we want? Not a full stop, Andrew. What do we want? We want the line length. Okay, and then value for the line length. We want the length, side length. Not line length, longer side. And that will be the value. And then what we need is we need subject response. Remember, 1 or 0 if it was left or right. Actually, you don't remember that because we haven't gone through that, but we will. We need to record the value that the subject has, or what the subject thinks it is. And then the final thing that we want is the latency. So the response, we'll just call it latency. And then we'll call that milliseconds. And then this will be value. Okay, so this is the data frame. And so now what we need to do is we need to create the arrays. The array of data that corresponds to the trial number. And so let's go up here above our main program loop. Okay, we don't need to see this anymore. We don't need to see this anymore. We definitely don't need to see this anymore. Okay, let's put this on a tree. Okay, so trial number equals an empty array. Trial number equals an empty array. And so main program loop here, let us go trial number dot append I. And so therefore it will basically into that empty container put the trial number that we're currently working on. And so if we go here, trial number now becomes trial number. Let's just remind ourselves that it's an array. So let's just call it an array again. Trial number array. Okay, so that one's done. Subject ID. Okay, so we'll call this sub ID array. And so here we need to import or include, okay, subject ID. Now there's a couple of ways that you can do this. We can create a GUI later on, which will come up and say, hey, enter today's experiment information. What we'll do at the moment is we'll just hard code this. And so we'll just say sub ID equals AG. That's my initials. Okay. And so therefore we need to create an array called sub ID array. We'll create an empty array now. Now you'll notice that this is actually a string. And remember, we're going to try and put a string into a data frame which also contains integers and also contains floats. Can it do that? Yes, it can, because remember, it also it accepts heterogeneous tabular data. So it accepts any type of data that we can probably throw at it. Okay, so subject IG equals AG. So if we have a look here, we go into our main loop and we'll go sub ID array dot append. We'll append into that the sub ID. Okay, brilliant. Now, what's the next thing? So this will be sub ID array, that's correct. The next value is the date. Okay, so we need the date value array. So let's create that now. The date value array equals that. And so how do we get the date? The date's probably not going to change when we run this experiment. So we can go date value equals date time dot now dot serve time. And what we want is we want the year. We want the date backwards, because then when we sort our data, it will actually sort it in correct chronological time. Have a think about if you try to do day first, and if you had experiments running over multiple days, what would happen if you tried to sort it just based on number? So year, lowercase m for month. Okay, so lowercase m for month, and then we want day, so lowercase d for day. And so therefore that should give us the date value backwards, and so therefore we will now append date value array dot append and then date val. Okay, now these things should be relatively quick to happen at the start of each trial. I don't think you'd need to worry too much about bogging down your loop timing. It should be quite quick. If you are finding that there are some problems there, then chuck it out of your main loop and just make sure you create an array of the same length for each of these things that aren't changing from trial to trial. date value array. So then that's date value array. Okay, so now we've got time. So this will be time value array. Now this will change on each trial, and so therefore we'll get time value array. We'll make that as an empty array. But then what we want to do is we actually want to get the current time for each time this loops over, because remember, it's going to take 7 minutes for that subject to get through those 140 trials. What is it? 40, 80, yeah, 160 trials. Okay, so time value array dot append, and now we want date time dot now dot dot strf time, and remember this is going to be hours, minute, seconds. Okay, so that should work now, and then that should be passed into this time value array. Great. Line length. Okay, so that's actually the array that we've created up here. We don't need to do it on every single trial now, because we've already created it at the start, and we're just looking into that for every single trial that we do. So line length array is the name of that. So line length array. Longest side. Now I think this is going to be stim length side. Is it capital S, is it? Let's have a look. We've got to make that a lowercase s. Line length array is there. Great. Stim side dot append line length array. No, it's lowercase stim side, so it's just stim side. Let me have a look. What are we? Stim side. Yeah, so it's just stim side, not stim length side. So stim side. Okay, subject response. We haven't built that yet. So let's create an array that now says, okay, sub response array, make it just an empty array. And then every time that subject responds, so any time that they press J or Q, we need to put a bit of information into that array. And so now what we're going to do is we're going to say, well, what did we say at the start? So F is for the left side. Okay, and so if they pressed left, we're going to call that 0. And if they pressed J for the right side, we're going to call that a 1. Okay, so left side is 1. So if left elongated, then it's 1. If right was elongated, then it's 2. Okay, so maybe what we could do is we could say, in fact, that if left side is 1, right side is 2. 1 and 2. Okay, so we have now our empty subject response array here. Great. Okay, so now, if they press the F key, then subject response array dot append. This is, they thought it was the left side, and we said that that's going to be the number 1. If, however, they press the right key, so they thought that it was the right side that was different, then they'll press the J button, and so therefore that will give us, we need to put in the number 2. So sub response array dot append, and we'll do that as the number 2. Okay, and so therefore we are creating our subject response arrays containing the number 1 or number 2 for that particular trial, and so therefore subject response goes sub response array like that. Now the latency, what are we going to do for the latency? Well, what we can do is we can set up a timer. Let's have a look at a timer. I wonder if there's a timer in Psychopy. Because what we want to do is we want to start a timer as soon as that stimulus is presented, and then we want to stop that timer whenever they press the button. Okay, so we'll go to documentation, and then we want to basically, if we subtract the time the button was pressed from the start time, then that will give us the latency between stimulus presentation and response recording. Okay, so I think it'd probably be under core.wait. Clocks and timers. Let's have a look at clocks. We will need millisecond precision here. So get time. What does it give us? Subfunction name, get seconds version. Is there a high accuracy? Get milliseconds or something like that. Clock, reset, countdown timer, get time. Sub-milliseconds precision. Returns the current time left on this timer. Okay, so we don't want that. Get reset time. Static period, complete, start. Okay. Let's have a look at monotonic clock, start time 0. We don't want any of that. Clock dot wait, get absolute time. The time, take time into account. Absolute times in seconds are especially useful to add file names. Yeah, that's true. John Pierce. Provides the high resolution time base used in Psychopy. So get time. Well, let's see what we get with get time. So let's run into our sandbox because we don't know what's going on here. I'm learning at the same time as you. We'll run into the sandbox. We will basically get rid of all of that because remember it's a sandbox, we don't need that. So from Psychopy import clock, because remember it's in the clocks and timers. And so what we want to do is we'll just print new line, and then we'll go time current sci time equals clock dot get time, print sci time. See what it returns. If it works, that is. 8.789688. Now, I think that returns the time from when Psychopy was initialized. Now, we don't care about start of time or the absolute value of the time. What we want is we want the difference between two timers that we set. So we want to basically probe a constant timer twice. And so if we go something like this, get time, and then, or we say something like first time call. So the first time we call that time equals something. So we go percent, say 3 values in front of the decimal place and 8 values after the decimal place. And we'll put into that sci time. Okay, something like that. And then what we'll do is we'll do a core.wait. So we'll wait for 2 seconds. We'll then get sci time 2 equals clock.get time. And then we'll say the second timer was this. And then we'll go delta time equals sci time 2 minus sci time. Then we'll print the delta t equals, and we'll go something like, I don't know, 3 values in front of the decimal point and 8 values. I'll just go 5 values after the decimal point, and we'll go percent delta time, something like that. Close that bracket off, make everyone happy. Clear this. We'll run this again. So hopefully we'll get a first timer. We'll wait 2 seconds, probe that timer again, hopefully after 2 seconds, and then we should return 2 seconds there. Okay, so there we go. So we made the first call to the timer at 5.799 seconds after initializing Psychopy. I think that's how it works. And then we waited 2 seconds, and then we've gone from 5.79 to 7.8. We subtract those two out, and we get 2.00089. And so that's what's that? That's 890 microsecond precision. Look, it's a behavioral experiment. I don't think we're expecting, greater than 5 or 10 milliseconds precision at all in our experiment. So I think this clock.get time is probably sufficiently good enough for what we want. Okay. So the process that we're going to do is we're going to start a timer we're going to get the time just as we present that stimulus. And then as they press that response button, F or J will get a second timer, calculate the delta time, and then put that into our experiment, into that array. Okay, so we will need clock in our line task. So go back to line task, right up the top, we will go, okay, up here, import event clock. So now we have to figure out, well, whereabouts do we want to start or get that first timer? And that will be just as we flip that stimulus onto the screen. So we'll just call it stim time start. We'll just call it start time equals, was it clock dot get time? Okay, so this is, that's still correct, that comment, but now what we're doing is we are starting our timer. Okay, we then present the stimulus and then we present the masker. Okay, key.event.wait keys, and then once they've pressed that button, we will then say stop timer equals clock dot get time, and then delta time equals start time, time minus stop time. Okay, stop timer. We'll start the timer. Okay, we're saying we're starting the timer, but we're just, probing the clock. We're just getting a single value of that clock, and we're essentially starting a timer. I think that's perfectly fine. Clock.getTime, clock.getTime, delta time. And then what we want to do is we want to we create a response? So response latency, okay, equals an empty array, and so therefore we'll go response.latency append. Well, in fact, we can just append the start time minus the stop timer. We don't need that line of code because we just want to append that into there. We do need that. And then what we're going to do is make sure that we do the same thing if they press the J button or the F button. Start time minus stop time, timer. Okay, that should be good enough. Now, this will be response latency. Response latency. Now we'll just print out that output data frame. Okay. Whew, we've done a lot of programming there, and I went through it pretty quickly, but hopefully you saw the thought process that that went along with what's going on. Now I'm just going to run this program. I think it should be okay. Now there might be some spelling mistakes and some errors, but we will sort that out as it goes along. I've made sure that I've saved this line task, and so therefore when we run it, button 3 line task .py, we should do this 40 times. I'll try and be as quick as possible. Okay, start time is not defined. So here we're debugging. Start time is not defined. So maybe we were meant to say, hey, start timer, start timer, start timer. Okay. We don't need to print this out, so we'll stop that print. So Command F, and we'll hit the print. No, we don't need to find it there. Okay, we need it here. Command F, find print. What is it? Be line. We'll just go print. Yep, okay, we don't need that. So my fingers are on the F, my fingers are on the J. I have no idea what that was. Okay, that's fine. Eight, 9, I think that's 9, 10, 11. So just have a look at what we've done. We've got a white background, we've got our fixation cross in the middle. We then immediately go into our stimulus, and then that stimulus is immediately followed by this really cool masking stimulus. I really like this stimulus actually, the masker. I think it's a really neat way of masking what's going on, and it's visually interesting. And we've learned how to do some Psychopy and Python programming for that. Again, I don't know what trial we're on currently. Okay. But it's a good habit to get into trialing the whole length of the program, because then you know, hey, it's working for the whole, 40 trials or 30 trials or 100 trials or whatever. Obviously, you don't want to do that all the time, because then you'll be there forever debugging a program. So make sure that it works in a limited scope first, and then work your way forward from that. By forward, I mean, work your way into the total thing. Okay, so here we go. We've got our file name here. So trial number, subject ID. Now, it's got ... there, because what it does is it actually truncates the output when you print it out. The subject response is 21122, so that's good. I can't remember what I pressed, but we can debug that later. And the latency in milliseconds. Okay, so that's actually in seconds, so that's wrong. So I need to change the name of that. So that's latency in seconds. Okay, actually, it is in milliseconds. So what we can probably do is... well, firstly, we've got a negative there, so we've actually got our timer around incorrect. It's actually the stop timer minus the start timer. Okay, so we have to make sure that we do that correctly. Stop minus the start. Now that's in seconds, and it looks like I'm responding at about 772 milliseconds there or so. So what we can do is let's round that. So let's round that value there to say 4 decimal places. Okay. And then what we'll do is we'll multiply all of that. So open, close. We then need another one there. We then need to times that by 1,000 to get it from seconds into milliseconds. So I think round is a function that we don't need to import any help with. Okay, if we do, we'll sort that out in a little bit. Okay, so what I'm going to do now is we'll go through that again. That didn't seem to take too long, and we'll see what we get out of it. I'm just going to alternate between F and J, starting with F and then J. So what I'm doing here is I'm just making sure that we're importing, or we're recording the number 1 and number 2 correctly. Left, right, okay? So every time you debug your program, try and extract out, some more information so you're not wasting your time. So there's 2 things that I'm checking here. Firstly, that our new timer will give us milliseconds, okay? And then it will give us a positive millisecondage. Oh, I forgot what I wrote then. That was an F then, so FJ. I've just done it again. I've got a very bad short-term memory. And that we are correctly recording subject responses. Okay, should be getting close to finish now. Okay, there we go. Okay, so something's not worked here. Why has it not worked? So the latency in seconds. Oh no. It's actually appended 1,000 times. Oh, I'm an idiot. I am a true idiot. Okay, so what we're going to do is we will have to do this in a couple of steps. Okay, so delta time equals stop timer minus start timer. Oh, wonderful. We need to round that. Okay, so we'll round that to 4. So round that to 4 decimal places, and then we'll multiply that by 1,000. Okay, and then what we'll do is we'll into this we'll then append our delta time. Okay, that's awesome. Okay, Command V. So let's just round the difference, stop minus start, to 4 decimal places, and then we'll times that by 1,000, because remember that was in to 4 decimal places. Does that make sense? Yeah, because then that's going to bring it forward. Okay, yeah, it will just shift that to delta time. So let's try this again. Why is it printing all that out? Do we need to print all that update stuff? No, because we've already learned that that's what we're doing. Okay, let's try this again. This will be the last time we try it in this video. I mean, we're going for 46 minutes now, so skip forward a bit. In fact, I'm going to pause it and we'll stop right at the end. Okay, so we're back now. So here we've got our output file, trial number, subject ID, subject response 12121212. So this is what I was doing. I was going between left and right. Now the latency 6,706. That's correct because I stopped my OBS recording, didn't focus back in onto that, and so therefore I had to click back in. It took me about 6 seconds. But here we go. We've got some pretty good latencies there: 300 milliseconds, 900 milliseconds, 1500 milliseconds, so 1.5 seconds. The precision of that is actually, again, it's a behavioral experiment. I don't think you'd expect to have a point something in the decimal place. I mean, 600 microseconds, that's just too precise. But obviously, it's all up to you. So we've created our data frame. Let's now think about saving that data frame to a CSV file. Now, the way that we can do that, because we've created our data frame this way, it is literally one line of code. We now say, we don't need to print it out anymore. What we're going to do is we're going to have output file .to underscore CSV. Now I think that's what it is. Let's just double check that. Pandas to underscore CSV. Data frame to CSV. So here we go. So this is the data frame that we've created, and we want to convert it into a CSV file. And then what we need to do is we just need to basically say, okay, well, where do we want to save it? And so what I'm going to do is I'm going to now just pause the video, go through my folders, and get the file path. Okay, 1 second. Okay, so here is the file path of the folder where I want to save this data. Users, my name, desktop programming, pyprog, line task. And so what we'll do is we'll go file, output, file path equals, and then we'll just put this here. Okay. We need to make that a string, so we'll get rid of that one. We'll put this here. Okay. Like that. And then the file name equals, we'll just call this line task. Oh, hang on. We can go sub ID plus line task plus .csv. Okay, and then output. Okay, so we'll go file path equals that, file name equals this, save path equals the file path plus the file name. What have I done here? Okay. What I've done is I've basically said, okay, this is the folder. This is the path that leads to the folder where I want to save the file. And then I said, okay, this is the file that I want to save. And then what I do is I add the file path and the file name together to create the total destination. The reason why I've split that up is because what we can do later is customize customize the different parts of this file path. Because what you don't want to do is hard encode everything, unless you want to just set and forget stuff. But typically what happens is you'll get a GUI, you'll create a graphical user interface where you say, okay, I want to save this file into there with this name, and so therefore it will create that file automatically. We're doing that by hand here. And we have to make sure that we've got the correct file format. .csv. Now, if you're running a Windows machine, you will need to do a double forward slash or a double backslash, so you can escape out of using the forward slash. Have a look on YouTube to see how to go about putting down the file path in a Windows machine. I'm pretty sure it's 2 backslashes, something like this, in front of every folder delimiter. Excuse me, sorry about that. So output file to CSV. Now we just have to give it the, so this is the data frame we want to save. The first one is where we want to save it, so save path. Okay, let's have a look. What else do we have here? I'll put that over there so you can't see it. Okay. We then have the sep. So what is the separator that we have? So the separator, what is the difference between each column of information? Well, in our case, it's going to be a comma, because it's a comma separated file. It might be a tab. So if you have a tab, so if you hit the tab between each data file, then it would be a tab. Or it could be a new line. Every time you see a new line, that indicates another column. Okay. So in our case, it's just a comma. Now, the other thing that we want is index. We don't want index, okay? We don't want to save the index, and so that should be false. I'm pretty sure this is correct. If not, we'll have to look it up ourselves a little bit later on. I'll get back to you. Okay. Columns to write. Well, we've already got that. That's in the data. The index, write row names, index. No, we don't want that. Index label, we don't want that. So there's a lot of other stuff there that we have that we just don't need. And so if all goes well, okay, what we should have, so here we are creating, create the save file path, okay, and then here what we're doing is we are saving the data frame, and it's literally that one line of code .to.csv. Once we've done that, we will then tidy up all of our resources. Windows closed. Let's see what we get. Okay. I'll pause the video. I'll go through and I'll show you what we get out of it once I finish. Okay. I'll be back in a second. Okay. And hopefully we're back. I've just done those 40 trials, and what happened? So it closed out. Okay, program window closed. I'm thinking to myself, oh, did it work? Did it not work? Well, there was no errors, and so that's a good sign. Now, I've saved it. I've saved our output file, okay, as a .csv file, in the same folder where I'm running the programs from. This is just for sake of simplicity. And so in Atom, what we can do is we can actually look to see what's in the current folder where we're running. And we can see here we've got another file. We've got our line sandbox.py, and we've also got our line task.py. You know, even if I list what's in here now, you'll see we've got ag line task.csv. And that's what we wanted to save it as. Subject ID, ag, straight into line task, great, .csv. This is great. And what it's done, if we just have a look at this very quickly, we just single click on that, and Atom will give us a look at, hey, what's going on in this file. We'll see we've got what looks to be a pretty good approximation of the data that we're trying to save here, with each of the values separated by a comma. And that's what we did here in our in our to CSV, where we said, hey, every one of our values is separated by a comma. So this is great. And we've got no index there. The index is false. So it looks to have worked. Let's see. The proof of the pudding's in the eating. So let's eat it with Excel. And here we go. I've just double clicked on that file. First column, trial number. I don't know if you can read that. Let me make this a bit bigger for you. Getting really excited here. So here we go. We'll go straight across there. Subject ID. Oh, let's go left. Let's go left. Trial number. So hopefully it should go from 0 to 39. Let's have a look here. 0 to 39. Brilliant. We nailed it. Well done. The next column is subject ID. The next is the date. And it should be the date backwards. So 2020-02-27. Haha, we did it. It's backwards. The time, 16:21:26. 16:21:28. Great. You can actually see the time when we did that trial. What was the line length? The line length for the first trial, the 0th trial, was 1178 pixels. Brilliant. We now know that we can work our way back to say, hey, that was 37 degrees of visual angle. So the longer side, so this 0, remember, what does this 0 mean again? Well, it meant that, let's have a look at our program here. Let's have a look at our bisect dim. 0 meant that it was actually a bisected line, and the subject responded with the number 1, and remember the number 1 meant that they thought that it was left longer. So we will need to do a little bit of cross correlation, I guess, between what we've encoded the data as and how we've saved the data and what the data means. Now this is where your lab book comes in handy. This is where your comments and your coding, the comments in your code come in handy. And guess what? We've also got our latency measurements here. 850, 681.5. Look at that. There we go. We now have a saved output file from a single block of our line bisection task. How brilliant is that? This is, we're living the dream here. A couple of hours ago, we started with nothing. Literally nothing. We just had a text editor and a paper that we wanted to replicate or to base our experiment off. Holy dooly, we've done it. What we're going to do in the next video, probably not today, my throat's getting a little bit dry today at the moment. What I'll probably do tomorrow is we'll basically do a little bit more of the interaction with the subject. At the moment, the subject doesn't know what they're doing. They haven't been given the instructions. So what I'll do in the next video, and I'll record that tomorrow, is we will learn how to put text onto the screen, and then also learn how to change our experiment ever so slightly so that our main program loop, will basically do all 4 blocks in one with a break between each one of them, if that makes sense. Because remember, they have to do 2 sets of blocks where they're told, hey, which side is longer? And then they have to do 2 sets of blocks with which side was shorter, okay? And so at the end of each session, we should have a spreadsheet, essentially, with 160 values in it. With those 160 values, 80 of those being which side was longer, 80 of those being which side was shorter. And so we will need to change a few things. No, we'll just need to add a few things into our experiment. And that's it, okay? So, wow, this is exciting. I'll leave this video here. Again, hopefully you've understood what we've done here. I did go through rather quickly the pandas side of things, the data frame side of things, and the saving side of things, and the file path and where to save and all that sort of stuff. There's a lot of information out there on YouTube and the Psychopy and Pandas documentation, where you should be able to get some idea of just exactly how to go about setting up your file paths. Again, if you want some more help, or if you want me to do some very short videos on how to do that, setting file paths and save paths and all that, more than happy to do it. Please just ask. But for now, we'll leave this video here. I'm going to get a drink of water, and high-five the dog. Because, hey, we've done it. All right? I'll see you later.